Welcome Wildcats. Today we're going to be looking at the next section of our HRW textbook, and that is going to be 4.8. Adding and subtracting rational expressions. So we've been talking about how to find rational roots and how to solve rational and complex equations. Now we're just going to talk about simply adding and subtracting rational expressions, which is similar to an equation except there's no equal sign and there's nothing we're solving for. So basically we're just simplifying these down as far as possible. There are three primary types of problems that your HRW assignment is going to have, so I want to give you an example of each of those. First, they might ask you what the excluded values of the expression is. Here's what they mean by that. It's any value, or sometimes there's more than one, that would make the denominator equal to 0. In order to find this, you're going to factor the denominator. So let's take a look at this for example. X minus 4 over x squared plus 2x minus 24. So the problem that we run into with a problem like this is that if you have something in the denominator with a variable, such as here we have a quadratic in the denominator, you run into the issue where there's a couple of values of x that if you pick those, the denominator is 0. And remember that the denominator is what you're dividing by. So in a case like this, if you plug in, there's two different numbers that when you plug them in, you're dividing by 0. And as you guys hopefully remember, that's not something that works in the world of math. So we call those times these excluded values. So let's go ahead and factor the denominator. X squared plus 2x minus 24. We need the factors of 24 that when one is negative and one is positive give us 2. So the factors of 24 that are 2 apart are 6 and 4. Because it's a positive 2x, we're going to have a positive 6 and a negative 4, because 6 minus 4 is 2, and 6 times negative 4 is negative 24. Now if you're not real comfortable with factoring, I am going to talk briefly about another way to solve this problem. But once you have these two items, you're going to take each of them, so let's start with x plus 6, and you're going to set that equal to 0. Solve for x. In this case, you have to subtract 6 from each side, and you get x equals negative 6. That's one of your two excluded values. To get the other one, you're going to take x minus 4 and set that equal to 0. This time, since we have x minus 4, we add 4 to both sides, and we get x equals 4. So if you plug in negative 6 to this original equation, you get divided by 0. So the equation itself does not work. The other way that you can do this problem is to graph just the denominator. And if you graph just the denominator, you're going to figure out where that crosses the x-axis. Those two times, in this case, would be at negative 6 and at 4, and those are going to be your excluded values. If you choose to do this graphically, make sure you are graphing only the denominator. The next type of problem that we might have are equivalent expressions. They'll give you one expression and they'll say, for example, 4x cubed divided by 4x minus 16. And they'll say, write an expression that is the exact same but has this as the denominator. Well, in order to do that, you're going to have to find the least common denominator first. Then you'll need to multiply the numerator by that least common denominator, and then simplify. So here's what we're going to do. I'm going to move over to the document camera. So we've got 4x cubed over 4x minus 16. And moving over to the document camera, 4x minus 16, well, 4x and 16 both share a 4. So I can factor a 4 out. So 4x cubed divided by 4 times. So if I take 4x divided by 4, that leaves me with x. And if I take negative 16 divided by 4, that leaves me with negative 4. Now that I'm here, I see that I have 4 divided by 4, so those can cancel each other out. That leaves me with x cubed over x minus 4. However, that's not actually the denominator that they wanted. The denominator that I need to get to is 4 minus x and x squared plus 5. Well, I see I have x minus 4 and this is 4 minus x. So that means these are a factor of, if I multiply either one of those by negative 1, I'm going to get what I need. So negative 1 is one of the items I need to multiply by. The other thing I need to multiply by that my current denominator, which is x minus 4, is missing is x squared plus 5. So I need to multiply my numerator by negative 1 and by x squared plus 5. Well, I'm going to multiply it by negative 1 first. So x cubed times negative 1 is just negative x cubed. And now I need to multiply it by x squared plus 5. X cubed times x squared is x to the 5th power. Times negative x cubed times x squared is negative x to the 5th power. And negative x cubed times 5 is negative 5x cubed. Now our denominator is exactly what we had before. That's 4 minus x squared plus 5. So this is our answer. These two fractions, the one that we started with and the one that we got as our answer, they actually say the exact same thing. They just say it with different denominators. That's why they're called equivalent expressions, because they equal the same thing. Let's go ahead and go back to our slideshow. And we're going to talk about the third type of problem that you're going to run into. It's going to ask you to add or subtract two rational expressions. So, step 1, you're going to find your least common denominator, just like before. Step 2, there's going to be more than one fraction. Whatever each fraction is missing from the LCD, you're going to multiply that fraction by that. I know it sounds a little confusing, but here in one sec I'll give you an example. Finally, you're just going to take the numerators and you're going to add or subtract them, whichever the problem says. So let's take this for example. I have 4 over 7 plus x, and then I'm adding that to 7 minus x in the numerator and x in the denominator. So once again, we're going to go back to the document cam and we're going to do this by hand. So first of all, for our least common denominator, which is step 1, I see over here I have 7 plus x. That is one of my terms. So 7 plus x. That has to be in my denominator. Here I have x. Is that the same as 7 plus x? Pretty clearly not. So that also has to be in my denominator. That was step 1. I have found the least common denominator. Step 2. Multiply all fractions by the missing portions. Well, here is my first fraction. Here's my least common denominator. This already has 7 plus x. So I don't need to multiply it by 7 plus x. But does it have an x? No. So I do need to multiply this by x. 4 times x is 4x, and 7 plus x times x is just x times 7 plus x. And we're going to have plus. On this side, I already have an x, so I don't need this x. But I don't have 7 plus x, so that's what I need to multiply by. So I have 7 minus x, 7 plus x is what I'm multiplying by. And then, just like before, x times 7 plus x is just x times 7 plus x. Alright. The entire reason we did that was because now my denominators are the same. And as you guys learned back when you first started working with fractions, when your denominator is the same, all you have to do with your numerators, if you're doing addition, is add them. If you're doing subtraction, you subtract them. So there is no real difference between addition and subtraction, except if you're subtracting, you subtract them. However, we do need to simplify this first. 7 times 7 is 49. 7 times x is plus 7x. Negative x times 7 is negative 7x. And negative x times x is negative x squared. We do still have this 4x over here. And we had addition between the two. So we have a plus 7x and we have a minus 7x, so those are going to cancel out. So we're left with negative x squared plus 4x plus 49. And our denominator is x times 7 plus x. Now, I don't know about you guys, I would usually write this as x plus 7. That's fine. Doesn't matter which order you write those in, as long as you have it fully simplified like this. Well, this section is probably going to be a little more complex than you're used to, because a lot of students have talked to me and they said, Mr. Atkins, I don't like fractions. And that's completely understandable. We're going to show you how to minimize the use of fractions, but for this section, they're looking for your answers written as a fraction. So we can't eliminate the fractions for this section, or HRW is just going to tell you wrong, wrong, wrong. Starting in the next section, though, we're going to show you how to reduce the amount of fraction work you have to do to the best we can, because fractions aren't easy for anyone. But hopefully these notes are going to get you where you need to be started, and as always, if you have any questions, find me or any of our other Algebra 2 teachers, and we are always happy to help you guys. But until then, good luck, Wildcats.